Hello, folks. Welcome to Rational Science, the only site on the internet that does physics rationally. Today, we're going to be talking about noumena. What in the world is noumena? Anyways, the subject matter is very much related to the flat earthers. In fact, people on both sides of the issue, flatlanders as well as those who oppose them, should become acquainted with noumena. Okay, and so today we're going to be starting with the flat earthers. Then we're going to continue with noumena. Going to go into that subject from the flat earthers, and then from there we're going to go into tie some loose ends on knowledge, and then followed by our science critic. Made a video of the scientific method, criticizing the scientific method, and we're going to address specifically the issue of what is an explanation versus what is a description. And then we're going to open the floor up for questions of people who asked questions since last time. So let's get on with the flat earthers. And this is where I'm going to start it. I'm going to start by showing what I think of flat earthers. Okay, I think they're very ignorant people and actually very stupid. And I do not apologize. I'm trying not to offend them. It's just a fact. These people have very little understanding of physics, and their reasoning abilities are even worse. Now, I am on record, okay? I'm on record saying that the flatlanders, the flat earthers, okay? These are people who are still as uneducated as they are. They are far smarter. They're like two notches above the mathematicians. Okay, the mathematicians fare a lot worse than they do. And why do I say that? Well, the flat earthers are ignorant people because they never went to school. That's their problem. The mathematicians, on the other hand, the mathematical physicists, so-called physicists, they've gone to at least 10 years of schooling to get their PhDs, and then they come out talking nonsense. They talk about Big Bang creationism, which they later deny. They talk about black holes. They talk about zero-dimensional singularities. They talk about dark energy, whatever that is. They say it's a measure of their ignorance. And it's like what is it, like 70%? So yeah, I think that really shows a little bit. It's a good number to put to the intelligence and the ignorance of the mathematicians. They tell you that a particle can be at two places at once, and that they can time travel, and that time dilates, and who knows what other nonsense that they learned by rote in college. So yeah, I have very little respect for the mathematicians, and in that sense, I put the flat earthers a little bit above mathematicians. Okay, so that's my starting point. Why do I start on the flat earthers? The other thing we should mention about the flatlanders versus the mathematicians is that the mathematicians, they don't believe the earth is flat. They believe the universe is flat. Okay, so yeah, forget about the earth being flat. Anyways, we started, or we laid off last time. We abandoned at the point where I showed how a balloon moves forward in a car when the car accelerates. And that's kind of counterintuitive, because you would think that, when anything accelerates, like a car, a truck, a train, whatever, you would think things go backwards. Turns out with a balloon, it's the other way around. Okay, and it looks more or less like this. Okay, here it is. Give it a second here. So the car accelerates and the balloon goes forward. And that kind of makes you wonder, why is that the case? You know, what's going on? Is this some fancy trick? It really seems counterintuitive, right? Okay, and we covered that last time. And then here, together with that idea, you find that if you move a water jug, forward, any bubble of air that's, on the surface will also move forward. And again, that gives you an idea that what's happening is the water moves backwards, and because it moves backwards, it's got more density than the air, so the air moves forward. Okay, it's got like more strength than the air. Okay, the liquids essentially drive the air away. Okay, and it looks more or less like this. As soon as the car accelerates, okay, you can see the water goes back and the bubble of air goes forward. Okay, so the bubble of air goes in a counterintuitive direction. You would think that everything goes backwards, and here they're showing that it doesn't. And that's more or less the case with air inside a car as well, why it pushes a balloon forward. The air allegedly moves backwards, and because of that, the balloon moves forward. Okay, so this is the explanation. Okay, and so I asked $1 million question, and I'm a little disappointed with some of the answers that I got from the flat earthers. Okay, and again, they're not very smart people. Uh, and so let me show you what the problem is, what the question is. And it takes a long time for these people to understand the question. So I'm going to insist one more time, see if maybe one flat earther or another can understand the question. I just want them to understand the question. Forget about answering it now. Okay, and so here's the question. Okay, you're on a subway or on a train, whatever. Okay, and you're hanging on, right? Suddenly the subway moves forward. Okay, you feel that you go backwards. Okay, something, for some reason you move backwards. Okay, and there you can see it, the second figure, the one in the middle, moving backwards. And if it accelerates even further, you move even further back. Okay, so that's our experience. Okay, and the question is, why do we move backwards? That's the $1 million question. You're standing still in the subway accelerates, you move backwards. Why do you move backwards? This is the $1 million question. Okay, and you'll hear some of the answers these people gave to this question. Okay, I call it a simple question. For other people, it's not as simple. Okay, and here's a dynamic version of something like that. You can see the car accelerates, and these two girls just fall off the truck. Why? What's pulling on them? Okay, that's the question. And people say, well, it's inertia. Well, that's not an answer. See, inertia is what we're trying to explain. In other words, we call this effect inertia, just like we call gravity an effect. We need the explanation for inertia. And you can't use concepts such as mass. You can't say field. You can't say wave. You can't say density. You can't use concepts. You have to tell me what physical object is in touch with the bodies of the girls that forces them down, that forces them, in other words, that creates that inertia effect. Okay, so that's the $1 million question. Okay, what physical entity is in contact with the girls? If you say there's nothing in contact with the girls, which is what most people would like to answer, then you're doing this by black magic. You're saying that there's absolutely nothing in contact with them, and yet they are pulled off the truck. That you're saying that inertia works by magic. That's what you're saying in effect. Okay, let me repeat that. When the subway accelerates, you move backwards. Why do you move backwards? What's pushing or pulling on you in the opposite direction of the subway, of the acceleration of the subway? And you say nothing is pushing, nothing is pulling on me, then you're doing that effect known as inertia with black magic. Okay, that's the issue. Okay, so what did one person reply? Well, he said the following. He says, talking about the airplane, because I used the airplane example, which was a bad example for me to use, really, because these people are not smart enough to understand what I was talking about. When you get on the airplane, they're already seated. That's when the airplane starts. It goes up in the air, starts going at a constant rate, more or less. And at that time, you can stand up, go to the bathroom, go to the front of the airplane. You can do whatever you want because you're traveling at the same speed as the airplane. The issue is here, what happens when the airplane accelerates? What happens to you? Okay? Hopefully it throws you to the back of the plane, but they didn't understand that. So because they didn't understand that, they didn't answer the question. So this fellow says, because yes, we are in contact with the plane floor. However, we are not attached. Okay? The plane seats do not move because they are attached, not just in contact. So the answer to your question is merely structure. That's the answer to my question. Structure. That's why when the airplane goes forward, you stay in place because you're part of the structure. That's what they're saying. And again, he's talking about constant acceleration or constant speed. That's not what I was talking about. I was saying, what if it accelerates? Okay, so again, he didn't understand the question. You can glue your shoes to the plane floor and you will feel like you are moving back, but you are kept in place as you are a part of the structure. Okay, he probably had a lot of help to figure all that out. Yeah, incredible the answer I got from him. And I think same fellow, I think he just put this up there. He says, horses go ahead and you, the driver, lurches back until the wagon, which is tied to the horses, pulls you forward. So you say, giddy up, horses run, you go to the back. And then once you hit the back of the seat, now because the whole carriage is moving forward, it takes you with it. My God, I think this guy deserves a Nobel Prize for discovering that. I hope he did it all by himself. Didn't need any help. Okay, another fella tries to answer the question, another flat earther. Nothing is pushing or pulling on me backwards in a plane. My body will move with the plane. Yeah, of course, if you're traveling at a constant speed, yes. But see, again, they don't understand that. If your mass of your body is at rest, it will go with the airplane's direction. Okay? When the airplane accelerates, it's the mass of the plane that makes the object inside it move. Mr. Mass is not a physical object, so you cannot say mass does this and mass does that. And it's interesting that all these flat earthers, some of them go to high school, they make it that far. And they learn all these concepts like mass and force and energy in high school. You don't learn them in elementary school, but yeah, you do learn them in high school physics. And so they use the word mass, which comes from mathematical physics, okay? And then they criticize mathematical physics, even though they use the same language that mathematical physics fed them. And that's where the problem is, because mathematical physics is nonsense. It's just math, has nothing to do with physics, okay? And these people are trying to explain something like mathematicians try to explain something, and you cannot use the concepts, the abstract mathematical quantitative concepts of math to explain mechanisms of physics, which is what the entire planet out there is doing today. They're using words like field and wave and energy and mass, force, charge. All these are concepts. They're quantitative concepts. They have nothing to do in physics. In physics, you have to identify the physical object that is doing the pushing or pulling. Okay? Like, if a horse is pulling on you, you say, well, why was I pulled? Well, because it was a horse. You can't say it was a concept called force. Okay? You can't say that it was energy. You can't say it was a field. No such monster. You got to say it was a horse. And so on, And here this fellow says it's the mass. So he thinks he answered the question, not even by a long shot. Okay? But then he says, once my body does reach the back of the plane, I thought he says it travels at the same, it travels with the plane at first. He says, nothing is pushing or pulling me backwards in a plane. My body will move with the plane. Now he says, once my body does reach the back of the plane, this is how these people talk. They just talk in circles. Then we'll also start to move with the plane again, as you can't leave the plane through its solid body. Poor soul. Bless his soul. Anyways, yeah, these are the kinds of answers that they give. They don't understand the question. They use concepts of math to try to explain a mechanism, and they thought they answered the question. It was mass. That's what it was. And again, mass in mathematical physics has two definitions or two general notions. One is quantity of matter, and the other one is weight. Okay? Now, the mathematicians never use the quantity of matter. They always use weight. So weight and mass are always synonyms because mass is always weighed, and they give it to you in kilograms. Quantity of matter, they would have to say, that the bag of marbles has 1 trillion atoms. And they would specify it in terms of atoms. They would say the mass of this bag is 1 trillion atoms. That they could do. They never do that. They always say the mass of this bag is 1 kilogram or 1 pound or whatever. So they always give you the weight. So in mathematical physics, weight and mass are indistinguishable. And the only time they try to change that is to try to explain that, if you take that bag of marbles to the moon, its weight changes, but its mass remains the same. And the answer is no. The mass the mass changed as much as the weight because we determine mass not by counting atoms, but by weighing. So when you weigh it on the moon, that's the mass of the bag of marbles. And until they count atoms and they express their masses in terms of quantity of atoms, they're not going to be doing mass. The mass of physics, which would be related to physics. As long as they use weight, a measurement instead of counting, okay? One thing is counting atoms, the other one is just weighing and giving you a measurement. Well, as long as they use measurement, they're doing mathematics. They're not doing physics at all. So, yeah, you can't use the word mass to explain anything anyways, even whether you use the weight or the quantity of matter notions of mass. Okay, here we have another fellow, and I said, what causes the air to accumulate in the rear of the car? And the fellow says, the motion of the container, meaning the car, right, is what causes the air displacement inside it, causing the air to move. All he said is, the air moves. Yeah, I know the air moves. We're trying to find out why the air moves to the back of the car. Why doesn't the air move together with the car? Why does the density become greater in the back of the car? That's the million-dollar question, okay? Something came in contact with each molecule, each atom that comprises the air, okay? Something is in contact with each atom. And so when the car moves forward, the air is left behind. Otherwise, why would the air move backwards? How does the air know that it's got to move backwards? Okay? And this fellow says, well, I guess he would say is that the back of the car is pushing, I guess that's what he's thinking, pushing the air in the back of the car. And the question there is, why doesn't the whole block of air move forward? Why does all the air suddenly move to the back of the car? He still hasn't answered that question. He won't answer it until he identifies the physical object that is in contact with each atom, with each molecule. Okay? And here he contradicts himself. He says there, the motion of the container is what causes the air displacement inside it, causing the air to move. The solidity of the car container, again, is causing it to accumulate in the back of it. Again, he hasn't explained it. He just says it is so. Okay, and that's not the question we ask. We ask, what is the cause? Okay, and here then he says, no air molecule is pulled anywhere. It merely falls back down to where it came from. So flat earthers have this idea that things that fall have been raised to begin with. This is their logic, if you can call it logic. Okay, and there's another fellow that also says something along the same lines. But the point here is that these folks are saying, that before something falls, it must rise. Okay, that's essentially what they're saying. But this fellow has not explained what causes the air molecules to go to the back of the car. Okay, the only way he can explain that is if he tells us what is in contact with each molecule, each atom that comprises the air, then he would be able to explain it. But to say that it just goes to the back of the car because the container, somehow the motion of the container, he hasn't explained it. Well, what is he saying? The motion of the container pushes all the particles to the back? Is that what he's saying? So again, you have to tell me what pushes that last molecule that's close to your mouth, right? What pushes it back to the back of the room? That's what he's got to explain. Okay. And where do they get this stuff? Well, they get this stuff from Mr. Galileo. Some people say that it was Newton, but no, Newton did not come up with the laws of motion. They were there before he was born. Okay. And so this is the Galileo so-called law of inertia. Again, ridiculous notions that the mathematicians have that they call everything a law. In physics, we have no laws. It's in mathematics that they have laws. I don't know who enacted them, who legislated them, maybe God, I don't know. But this is the short version. A body will remain at rest unless it is acted upon by a force. A force? Maybe he meant the horse. See, a horse can act upon an object like a carriage there, but not a force. There's no physical object called force. So you cannot say a force does this, a force does that. Okay? Not in physics. You cannot cut corners and say, well, I'm going to use euphemisms or figures of speech. No, you can't. You got to be literal. So when you look at this, you say it was the horse that pulled on the carriage, on the buggy. Okay, that you can say, but you can't say a force pulled on the buggy. Okay, and so again, mathematicians invented these words, and then they extrapolated them onto physics. No, when you come into physics, you have to put a physical object there. You can't say the force did it, the energy did it, the mass did it, the charge did it. You can't use any concepts. Mathematical concept, quantitative concept. You have to use physical objects. You got to tell me what physical object moved this and moved that. Okay, that's the issue. Okay, so Galileo did not figure it out. Again, all these people talk about force and other concepts, and that's when they screwed up because they're doing math, they're not doing physics. Okay, so let's distinguish those two. Okay, so a lot of these people, they harp on experiments. They want to do experiments. So let's do an experiment. I mean, they all want to do experiments. Not only the flat earthers, the electric universe, John Chappell group, the establishment. Everybody talks about experiments. That's what they inherited from the 17th century so-called scientific revolution. Okay, so let's do an experiment. And it's known as Newton's bucket. Okay, we're going to try to figure out if there is something, a physical entity, okay, in contact with the air inside a car. Okay, is that possible? Or is it that we're all crazy? We're just saying that air just, the container hit the, the air and that's why it accumulated? No, we have to identify something, and Newton's bucket is a good experiment for all those flat earthers to become acquainted with, okay? And let's go through it real quick so they learn something maybe. Here it is. Okay, here's Newton's bucket, okay? We fill a bucket with water, and we hang it from a rope, okay? Now we're going to torque the rope as much as we can, and then we let go. As soon as we let go, the water momentarily, while the bucket spins, right? The water initially stays flat, the surface stays flat. But as the bucket spins more and more, what you get is this concavity. You have concave water. The water rises at the edges and sinks in the center of the bucket, okay? And when the rope stops spinning or torquing, when the bucket stops, the water is still twirling around and with that concave surface. Okay, so this is Newton's bucket experiment. He did it in those days, I think 1687, somewhere around there maybe. Anyways, this is the experiment. Okay, you twirl a bucket and something which is not the bucket. Okay, by the way, and I'm not going to go through all that. You can look it up. Something outside of the bucket, in fact, outside of the earth, is pulling on that water. Let me repeat that for all flat earthers out there. Something outside the earth is pulling on the water, on the molecules of water. Okay? Now, this is where it gets interesting because flat earthers say, well, how do you know that? And blah, blah, blah. And they start, getting all excited. Okay? So let's go step by step. Let's show the flat earthers how much intelligence they really have. Okay? So here was Newton's version of what pulled on the water at the edges of the pail, okay, and why it formed that concave surface, okay. Well, first of all, let me show you. This is, again, you see the skater, and when a skater twirls, her arms are being pulled by something. Okay? And the question is, what is pulling on her arms? She feels her arms stretching outwards. And you don't have to take my word for it. You can go and talk to one of these skaters and they'll tell you that when they spin, their arms are like being pulled somewhere. And hopefully it's not the air around her that's not pulling on her arms. So what you have to tell me is what is pulling on her arms. And this is the same situation as the air inside a car. This is exactly the same situation as those girls who were dropped out of the wagon there. And they fell on the floor because the car accelerated. So all these are the same situation. Something is pulling on matter here on Earth. And Newton was saying that it was, and in fact, all the mathematicians out there in this are saying that it's something outside the Earth. And for once, they got this one right. They just don't know what it is that's pulling from outside the Earth, okay? So what's Newton's version? Here it is. Newton said it's space, okay? He said that when that bucket twirls, it twirls with respect to space. There is an absolute space out there, and everything gauges its motion with respect to space. That was his version of it. Leibniz did not agree with him, but he had no reply to that. He couldn't figure it out either. Mathematician from Germany. Okay, a couple centuries later, we have another fellow come in, and his name was Ernst Mach, and he came up with the notion that it's not space, but mass. Okay, he was talking about the mass of the stars. And again, now these people talk about mass, but mass is not a physical object. You cannot say mass pulls on water. Okay? You cannot say gravity pulls on water. Those are irrational statements. Okay? And so again, one of the things you got to keep in mind is that you can't just keep putting concepts there and hopefully getting by with just a concept. And saying, you have this invisible mathematical concept, quantitative. It's just a quantity with a number with a unit, and that's pulling on the pail. That's pulling on the water inside the pail. So this is the problem. And so they summarize it as this, essentially Mach's principle, created by Einstein, who gave him credit for it. He said the paradox of mass there influences inertia here. Where's there? There is outside the universe. He said it was the stars that pull somehow, okay, from a distance, action at a distance, somehow pull on the molecules of water. Okay, do we have that? And I should have brought what I showed several times already, and that's Richard Muller, professor at Berkeley, and he said every atom in your body is being pulled by every atom on Earth. Okay, so we have all these notions out there. Here's Einstein's version of what is pulling on you. In his case, he says it's warp time. Okay, And NASA said they proved it with experiment known or project known as Gravity Probe B. They proved frame dragging. They say that the Earth drags space around itself. This is the nonsense with which all these PhDs at NASA, Houston probably, came up with. Warp time. So this is what all these people have come up with. In other words, to this day, we have no answer to the question. They have a partial answer that's the universe, all the stars somehow are pulling on us. They're in contact with us somehow. And the way the mathematicians answer is, well, it's mass, it's gravity. But those are concepts. You can't say gravity pulls on you. Gravity is what you're trying to explain. You can't say inertia pulls on you. Inertia is what you're trying to explain. And you can't say mass pulls on you. Mass is what you're trying to explain. Why does mass, increase its speed, right, acceleration, as it falls towards the center of the Earth? Okay, and you can do that on your own. You can take a bowling ball and weigh it on top of Mount Everest or a high point somewhere, weigh it at the low point, sea level, whatever, and you'll find that there's a difference in weight, very small one if you do it at the same place, more or less, up, down. And you'll find that there's a small difference in weight. Okay? And so the acceleration is greater as you reach the center of the Earth. So what you have to explain, what is pulling on you. Now, if you say it's push, okay, fine, explain it with push. But you got to explain, but in order to explain, you need to identify the physical object that is pushing or pulling on you. Just like you would explain how you're pulling on a donkey, same thing. You got to explain what is pulling or pushing on whatever that's causing, these accelerations. And again, if you have the skater moving around, right? The more she spins, the more her arms are being pulled outwards. Why are they being pulled outwards? What's pulling on them? Okay, that's what you got to answer. And in order to answer that, you have to identify the physical object that is in contact with her hands, her arms, her body. Okay, mathematicians say it's something outside the Earth. They never figured it out. Some say it's space. Some say it's the mass of the stars, which is more or less the idea they have today. And then, which is Mach's principle, essentially. And then you have Einstein said it's warp time. So that's state-of-the-art explanation for you of inertia. Okay. Moving on, more or less the same issue. We have gravity. Okay, we had inertia just a minute ago, so now let's do a little bit of gravity. And here a fellow says the cause the pencil drops. You let go of the pencil. Okay, my famous experiment. You let go of the pencil and it falls down. Okay, and so what the flat earthers all say says, well, the reason it falls is because you pushed it up. This is their logic, if you can call it logic. So I pushed it up, right? Pushed it up, and now, because there's nothing to stop it, that's why it falls down. That's their answer. Okay, so they haven't answered anything because I need to know what's in contact with a pencil. Okay, but let's address that first issue. So the cause of pencil drops is the absence of matter beneath it. Okay, great. The object will fall down until it meets a more dense medium that resists it. Not that hard. Poor fella, he must have worked all night to come up with that answer. Okay, I know it's hard for them. You picked it up, you dropped it, you observed the effect of your own cause. So the cause, see, I dropped it. I didn't push it down. I just let go. See, let me make sure we understand. I'm not going to push it down. In fact, I can push it upwards and it'll fall down anyway. See? It still falls down, whether I push it up or down. So it's not that I pushed it down. Okay, I want to make sure that people understand that. I just let go of it and it falls. So no, I'm not the cause of why it goes down. Okay, so no, he answered it. he didn't answer it at all. But we have stuff like asteroids. Do you believe in asteroids, flat earthers? Do you believe in meteorites? You can see them every day. They fall on Earth. There's all kinds of debris falling on the Earth from outside the Earth. We didn't throw that debris out there and wait for it to come down. We don't throw meteorites out there and then say, okay, now it's going to fall. Meteorites come from heaven, God, I don't know, I don't care. But they don't come from the Earth. They come from outside the Earth, fall on the Earth. No one pushed it upwards. Okay? And so the question is, why do they fall to Earth? What's causing those meteorites, those stones, right, to fall to Earth? That's the $1,000,000 question for you. Okay, so don't tell me that I lifted the pencil and that's why it fell, because I didn't lift the meteorite for it to fall. Okay, we got that? Very simple stuff. Well, for normal people. Okay, but maybe you can get past that. And another fellow says more or less the same thing. Show us how a spoon or bowling ball can fall without it being lifted up first. You don't seem to understand that most objects just don't float in midair or fall upwards after being lifted and then released. And again, meteorites, don't talk about stuff that you are familiar with. Talk about stuff that you're not as familiar with, apparently, which are meteorites, asteroids. Here's, let me show you a list here, impromptu list that I've got. And that's, the first one says, chunk of rock falling downhill. Now, you can argue that in that case, maybe the mountain pushed it up originally because, the mountain grew over time, right? There are all kinds of tectonic movements, and so they tend to push mountains upwards, at least that's the theory. And so the question is, you could argue that the rock was pushed up originally. Fine. Bird laying an egg in a nest. Okay, again, we have the situation where the bird, she was probably not pregnant when she went up there, but you could say that the egg was manufactured in her body, and so whatever she had in her body, she took up to the nest to begin with before the egg could drop to the floor. So again, you can argue that, right? Rain, snow, fog, same thing. You could argue that there are, these hot and cold air that mix up there, so you could argue that the air went up first before it came down as rain or fog. Okay, but here we have other situations like the air itself that covers the earth, right? Uh, we didn't lift that. Okay, and so the question is why does the air fall? Because there's air that falls, and the question is, did that air first rise? Is that what you're saying? That there are air currents that took it up? Well, you have stratosphere. You can have that air up there, and then some of that air trickles down. Eventually, some of those atoms, some of those molecules. Okay, and so the question is, does air fall, and did we put the air up there? How about the moon? Especially for flat earthers, the moon, when it rolls around the flat Earth as moon and the sun, by the way, does it roll around the flat Earth like they say, and there's just these disks? What does that fall? Did we put the moon up there? Also, we raised the moon up there before it fell, and why doesn't it fall? Please tell me why. Okay, what causes it to go around? Why doesn't it fall? Okay, you would think that it would fall, right? What is it, a balloon? Oh, it's not. You don't believe in spherical balloons. Maybe it's a flat balloon, a pancake balloon. And again, asteroids and comets, meteorites, they fall to Earth and or to any object, and we never put them up there. Okay, so to say that objects must be first pushed up before they fall down, that's a non-answer. Okay, we don't need to put anything up for it to fall. Okay, fellow says along the same lines, and this all goes to what we're going to be talking about today, which is noumena. Okay, and here we see this fellow says, yes, we have a flat moon. These guys are real. Use your eyes, not your mind. Well, obviously you haven't used your mind very much. Okay, I grant that. You are telling us that there is something between the magnets we can't see. Exactly. I'm saying exactly that. I'm saying there's something between these two magnets, the two round ones, okay, the two round ones there, and they stick together. And there's something here we can't see, but I can already feel it pulling. And it's taking it out of my hand. And it's not that I feel something pushing from the outside. It's something from within, okay, between the magnets. So yeah, there's something there. And you might say, well, let's continue. He says, you are stating something is there without demonstrating this. Uh-huh. How is that not black magic? Well, it's the other way around. If you tell me that there is nothing between these two magnets, okay, because you can't see or touch them, which is what all these people want, experiments of some kind. Experiments meaning sight and hands, sight and touch, eyes and hands, right? That's what they're looking at. They're saying, let's go to the lab and see if we can see what's in there. And of course, they're not going to see anything because, again, whatever's in here is invisible and intangible, okay? We can't touch it with our hands, at least. We can touch it with iron filings, but we can't interview the iron filing and find out what it touched. That's the problem, okay? We can't touch it. And for sure, we can't see it. But if you say that there's nothing there, then you're saying this happens by black magic. It just happens. No explanation whatsoever. No mechanism, no cause. It just happens. It's one is pulling on the other, and because you can't see anything there, you say, well, there's nothing there. Okay? And yeah, that's going to take us to the subject matter of today. Okay? But so let's just rub it in what the question we need to answer. Flat earthers need to answer these questions. Here you are in the subway, okay? Subway moves forward, you are physically compelled backwards. What is pulling on you? Why don't you travel together with the accelerate? Why don't you accelerate together with the subway or the train or whatever, or the bus? Why does the bus go and leave you behind? What's holding on to you? What's pulling on you? What's pushing on you? Something is holding on to you. Okay? Like that fellow said, if you're stuck to the ground, you would be moving with the vehicle. But since we're not stuck to the ground, obviously you move backwards. I mean, that's our experience, right? The question is, why do you move backwards? Okay, you say, well, because the other guy moved forward. Yeah, but you could. Are you standing still? Is that what you're saying? Okay, what's holding you there? Why don't you move with the car even though you're not attached to the car? I mean, you should be able to move with the car. Why is there a difference between being attached and not being attached? That's the question. Okay, so you got to tell me what's holding on to you, or what's pushing or pulling on you. What invisible, intangible entity is in contact with your body that compels you to, be pulled backwards when the vehicle accelerates? That's the million-dollar question. Okay, and to say, well, it's density, it's inertia, it's gravity. No, that's what we're trying to find out. What is gravity? What is inertia? What is mass? That's the question. Okay, that's the ultimate part of the question. And the only way you're going to answer is identifying the invisible, intangible objects that Mother Nature uses. Okay, here we have, well, it says, someone says, there are infamous flat earther who fully believe the moon landings and ISS. I don't think so. These people are dumber than normal flat earthers. Okay, they're even dumber because if they believe that we went to the moon, and if they believe that we have the ISS rolling around there, well, we have satellites out there, and this is how many satellites we have out there. Okay. 7,400, okay, individual satellites in space at the end of April 2021. So if we have these many satellites from different countries, any one of them can take a picture of the Earth from far away or from a certain distance and tell you that the Earth is spherical, that it's got a curved border. And, people say, well, how do you believe that? Why do you believe that it's got a curved horizon, et cetera, et cetera? You're saying all these satellites, different countries, they're all in cahoots and they're all trying to fool you. Oh man. If I were you, I'd watch my shadow every day. Who knows? Maybe they're after you. No, any satellite from any country that's out there. I mean, you have Japan, you have so many countries that sent satellites up there. Any one of them can take a picture of the Earth. In fact, you have Google Earth, uh, and hopefully you see it roundish, roundish surface. If with so many satellites out there, to say that all of these are hoaxes, that all the pictures that they've taken, for example, the ISS rolling around the Earth shows always a curvature. If you say that's a hoax, well, where did you get that? Why do you think it's a hoax? All countries are hoaxing you, and again, yeah, you must be scared of your own shadow then. Okay, and so someone gave me a good response for what I can consider now a definition of a flat earther. It says, by the uninitiated, I mean people who believe in nothing but what they can grasp in their hands, who will not allow that action or anything invisible to have real existence. That's more or less summarizes the flat earther. Flat earther does not believe in what we're going to call today noumena. Okay, and we'll find out what that is all about. But essentially, a flat earther only wants experiments and wants anything that they can see and touch. That's how prehistoric they are. They say that's all I can put my finger on and say this is true. And anything else is just a lie, a hoax by the intelligence agencies. So they don't want to believe anything other than that. And so if they can't see it and they can't touch it, it doesn't exist. That's essentially what it comes out to. And again, it's because they have the wrong definitions, irrational definitions, the see-touch criteria for object, the see-touch criteria for exist and existence. And those are not the definitions of object. Those are not the definitions of exist. That's where the problem is. So what does a flatlander want? Well, he wants proof. So the definition that you just saw is very specific for them. It's right on the money. We want science based on our human senses, except common sense. Okay, all other senses. They think it's all about see and touch, especially those two. Smell, which is touch, hearing, which is also touch. All those are touch. You have to have some contact, but essentially it's see and touch. And so they don't want to get away from that. And it's like their world is so small, that you ask them, is a table an object? Yeah. Why is it an object? Because I can see it and I can touch it. Is a chair an object? Yeah. Why? Because I can see it and touch it. Tree, I can see and touch it. Rock, I can see and touch it. So is the rock that's on the other side of the planet that you cannot see or touch, is that an object? Does that exist? Okay, so that's the issue. Because if you're going to do everything by see and touch, the moon does not exist for the blind man because he can't see it. And air must not exist for you because you can't see it. You say, well, I can touch it. Yeah, but you can't see it. What are you touching? Please draw for me what you're touching, that invisible stuff that touches your hand. That's what we want to find out what it is. What is air? Is it a ghost? Is it a spirit? Okay. Please draw what air is. That's the question. Okay, and it says an object is not what I can see and touch. That was my definition. So he's saying an object is not what I can see and touch. Wow, I guess I learned something new today. Yeah, I guess he did. Whether he learned it or not, I don't know. How is one to ever prove something exists if he cannot see or touch it? And you can see how they confuse the word object with the word exist. They make those two synonyms. They think an object is that which you can see and touch, and existence is that which you can see and touch. So for them, the word object and the word exist are synonyms, And that's been the case with 99% of humanity today. Okay? So in that sense, they all have the same notion that an object is that which you can see and touch. Okay, and so he says, how do you prove it? He thinks he's going to prove existence. You prove the existence of the chair by touching it and sitting on it and seeing it. And so again, is the chair that's on the other side of the planet, is that an object, first of all? Because you can't see or touch it, so I guess it's not an object. So what is the Japanese or the Australian sitting on? I mean, is he sitting on an object? Does that object exist? And you're saying, I got to see it and touch it, but otherwise it doesn't exist. So again, their notion is their little world inside their tiny minds. Okay, it's this little tiny world that they have there, and their whole world just goes in that area. Okay, I thought maybe someone cut me off there. So they have this small world, and it's just whatever they can see and touch. They cannot go beyond that. They receive a call maybe on their cell phone from Japan. Where's that coming from? Does that person exist? I mean, you can't see him or touch him. Does that person exist? Is that person an object? And they don't have the mental capacity to understand what I just said. They don't realize that there's someone who called them on the phone. Who do they think called them? God? I mean, I don't know. So you want us to accept all these concepts without proof. See, again, they harp on proof, on evidence. They don't want an explanation. They don't want a mechanism. What they want is for you to convince them. That's the issue. Okay? And if they can't see or touch it, they say, I'm not convinced. And so you can't see or touch the person who's on the other side of the planet who's calling you, so that person is not an object, and that person doesn't exist. Okay? And so take your word for their existence. And again, they mix the word object with exist. That's one. And then exist is not see or touch. Okay, so these are the gross errors in logic, if you can call what they do logic at all, rationality. And they just mix these things up, object with exist, and why? Because they don't have definitions. That's the issue. They don't work off of scientific definitions. They use the definitions of ordinary speech, and in their tiny little minds, that's what they live with. That's all they've got. So when they come into the scientific world, they bring those definitions of common speech, of everyday speech, and they think they're making sense. They say, oh yeah, object, that which I can see and touch, exist, that which I can see and touch. And what about the objects that you can't see or touch? Does the air exist? I mean, you can't see it. You say you touch it, but what did you touch? Maybe you touched a ghost. I don't know. Okay, so these are conclusions. Flat earthers misunderstand basic physics. They are very, very ignorant people. Okay, no apologies there whatsoever. Okay, they harp on belief rather than on explanation. They don't want an explanation. They don't want you to explain a mechanism. What they want is for them for you to convince them. They want you to harp on their belief system. And they withhold belief because they say you haven't proven that there's air. Because I can't see it. And you haven't proven that Australian is sitting on a chair because I can't see or touch it. So that chair doesn't exist. And that's the guy that called you just now. He was sitting down calling you, but he doesn't believe that because he doesn't see it. He can't touch it. So he says, that Australian doesn't exist. And he's not an object either. But someone called him, who knows. Okay, maybe it was his mother from New York. He doesn't see her or touch her either, but he says, oh, Ma, how are you? Who are you talking to? I mean, you can't see or touch her. Okay, so what do flat earthers have to do? Well, they have to answer the cause of inertia. Okay, and these are some of the things that they can address. One, what causes the air to go to the back of the car? Okay, what causes the air to go back? What thing is in contact with the air molecules? Draw it. I want you to draw whatever's in contact with the air molecules. And again, Mach's principle, Newton's bucket, says that something outside the earth is pulling on every atom on earth. And when the skater rotates, her arms are pulled outwards. Tell me why. What's pulling on her arms? Okay, or maybe pushing. I don't know. Maybe you want to do push gravity or push inertia. Fine. What pushes and pulls pulls the pen to the floor? Okay, we have the pen or pencil, right? Let go of it. Again, I'm not pushing it downwards. It just falls. Why does it go down? Why does it go upwards? That's the question. Okay, why doesn't I want it to go? Someday I want it to go to the ceiling. Okay, and what brings two magnets together? Okay, you're saying there's nothing here, then you're doing black magic. That's what you're doing. Because you're saying that this comes together with that one for no reason whatsoever. And it always does the same thing. You know, it just comes together. In fact, if I hold it lightly, you can see how it just goes by itself. And you're saying there's nothing here simply because you can't see or touch it. Okay? That's the issue for you. Because for you, an object is that which can be seen or touched, and existence is that which you can see or touch. And again, I can show you that you can't see or touch the person on the other side of the planet, meaning that that's an irrational definition, an irrational notion that you have of what an object is and what existence means. Okay? Action at a distance, any action at a distance, black magic. Like everything from mathematical physics. You know, they talk about entanglement, they talk about gravity, they can't explain it. Why? Because they never identify the physical object that we cannot see or touch. So you cannot use the see-touch criteria. That's the issue. Okay, and if you're using concepts such as field or mass or density, you know, any of those, you're doing black magic because you cannot say density does this and I don't know, mass does that. You can't use the concepts as physical objects to explain a mechanism. Okay, so we got that. And what you need to do is identify the invisible, intangible mediators that Mother Nature uses to do her daily work. Mother Nature, Father Universe, God, the devil, whoever you pray to, I don't care. I need to find out what those physical objects are, those invisible, intangible objects that they use every day to do gravity, density, mass, whatever you want to call it. Okay, so that's the homework. Okay, if you can do it. And final note, Fowler says, let me put it over here, says, first telling why the concept of visualization is so important, and then immediately after discarding Einstein's theories completely. Laugh out loud. Well, I'm not sure he's laughing at himself because he's laughing out of ignorance, because Einstein never had any visualization whatsoever. Okay, so let's get that straight. All of Einstein's nonsense was all abstract math. Never did he have a mechanism, a physical mechanism for how the universe works. To say that space-time warpage, you know, is what causes gravity, that's absolute poppycock. Okay, so you can't say that he illustrated anything, that he made something visual for us. Absolutely not. In fact, to this day, most mathematicians will tell you that they have no answer to that. When you say, well, how about space-time, this canvas? Now you're taking the analogy too literally. That's the answer you get. In other words, they don't have, to this day, a physical mechanism, objects, things that explain how gravity works, how inertia works, how mass works. They don't have that. All they have is mathematical equations, mathematical concepts. That's it. Okay, so we got that. Now you know what your homework is. Okay, figure out inertia. Figure out why that girl spins and her arms come outwards. That's what you got to figure out. And I would advise that you look up Mach principle, Newton's bucket, so that you become familiarized with the invisible, intangible things that are in contact with our bodies from outside the earth. Let's move on to noumena. What are noumena? Well, it comes in very handy today because that's exactly what flat earthers don't believe in. Okay, in fact, I would say 99% of humanity doesn't believe in noumena. Okay, this word was invented by Immanuel Kant, maybe, And what he said is that some objects we can touch and see, but others we can't. They are objects, you can say, of the mind. Okay, we can imagine them, we can visualize them maybe, and they're only in the mind. Okay, and so you got to think about that, because people say, well, if it's in the mind, it doesn't exist. Well, not necessarily, see, because you can make an assumption about an object that you cannot see or touch, which is what noumena is all about. And you can say, well, what if there's an object you cannot see and touch that mediates gravity, that mediates inertia, that mediates mass? Okay, so that's the issue. So let's go with Mr. Kant, see what he says. And these are summaries of essentially of his main points. He says, noumena, objects of the understanding, okay, that can be given an intuition, although not to sensible intuition. In other words, sensible meaning senses. Okay, so they're given to intuition, but not to the senses. And the comment that you'll find in the Stanford Encyclopedia is, clearly we do not cognize any noumena, since to cognize an object for us requires intuition, and our intuition is sensible, not intellectual. Okay, so they're saying that, or at least whoever wrote that piece says that they cannot imagine even something like noumena existing, because intuition doesn't work through the mind. Intuition works through our senses, and phenomena are related to senses, and noumena are not, and so that like automatically disqualifies them. That's more or less the argument there. Okay, that's one take on that. What did Mr. Kant conclude? Essentially, this is a summary again of his conclusions, right? We know the noumenal world to exist because human sensibility is merely receptive. In other words, when you touch, when you see, okay, that's receptive. That depends on the individual, on the observer, right? However, it is not itself sensible, the noumena, right? And must therefore remain otherwise unknowable to us. So they're talking about the unknowable noumenon. Right now we're looking at two things. On the one hand, they're saying, look, phenomena is that which you can see and touch, whereas noumena you can't see or touch. It's there, or at least you posit that it's there, but it's unknowable. And again, they use this word know, which no one ever defined. In other words, you don't believe in it, because that's what knowledge is, belief. Okay, so this is where the problem comes in. They introduce words or situations that have no bearing on the issue before us. Are there objects that we cannot see or touch? Are there phenomena that we cannot see or touch? That's the question. Okay, so here we have, let me get this one out of here. The definition that we find at the Wikipedia this is after, I mean, you're talking about, I think, 1781 that Kant wrote the Critique of Reason, okay? And here's what we've come up with after 200, 300 years since that book. Noumenon, object or event that exists. Big problem there. We can say that an object can exist. We cannot say that an event exists, a happening exists, an occurrence existing. Okay, what do you mean when you say that an event exists? So big problem there already. But it says object or event that exists independently of human sense and or perception. You cannot expect to sense this with your eyes, with your hands, with your ears, with your smell, nothing. Okay, you can't sense these objects known as noumena, plural, noumenon, singular. But you look up the word object. It says object or event that exists independently of human sense, right, or perception. Object, a thing observed. Of course, if you're going to define object as a thing observed, and again, that's a definition that the Wikipedia links, right? If a thing is that which can be observed, then that automatically rules out noumena because you cannot observe it by definition. So we have a contradiction already there, okay? And continues there, it says, objects may not have real existence independent of the subject who observes. Again, introducing the observer, the person who's the judge, so to speak, right? At issues whether objects can exist independently of their properties. And again, they put the word exist always with the word object. Okay, it's like they cannot separate the word object from the word exist. Okay, and by that I mean that if object is that which is observed, meaning see, touch, exist is also by default see, touch. That's what it amounts to. You look up the word event because it's object or event that exists. You look up the word event and it says it's a phenomenon. So events are phenomena. You look up phenomena, it says an observable event. Typical of mathematicians. They never learn how to define key words. So they go around in circles. You never know what they say because they never define their language, the key language with which they have to make their case. So we haven't learned anything from these people at the Wikipedia, and that is essentially a summary of what people know out there, the state-of-the-art knowledge of the scientific world. In many ways, it's condensed in there. Okay, maybe not in fine detail, but it gives you an overview, and this is where they're at. They haven't defined any key word. They don't know what exist means. They don't know what an object is. They don't know what distance or location is. They don't have a definition for any of these words that form the foundations of physics. Okay, what do the mathematicians consider noumena? Okay, the mathematicians, as I call them. Okay, this is mathemagy. They say, essentially, right? Noumena are unobservables. You cannot observe them, and of course, mathematics does not vouch too much. They don't care too much about stuff that they cannot observe, meaning see, touch, and so they think that this stuff belongs only to philosophy. Okay, so if there are objects that we cannot see or touch out there, we can't see the air, right? We can't see the chair. The Australian sitting on the other side of the planet or touch it, right? So we have a problem. First of all, is it an object? Does it exist? And mathematicians don't go that far. They just worry about their little world just like the flat earthers. So we don't have an answer to those questions. Obviously, the definition, the see-touch definition, the criteria used to define objects and existence, it's irrational. You can't use those definitions in science. We need to redefine all those words because they do form the foundations of physics. Okay, so this is my take on that. You have to define these two words, object and exist. What is an object? That which has shape. What is exist? Well, it has to have location. What is location? The set of distances to all other objects. Okay, so in order to exist, we have to have all other objects in the universe. That's essentially it. See, if God wants to exist, God first has to be an object, a thing. And there you can see that looks like God is a thing because God has shape, as I see a shape there. Okay, so God seems to meet the criteria of the definition of object. So God is a thing, but that's not enough to exist. If God wants to exist, also has to have distance with respect to all objects that exist. Okay? There's got to be a straight line of direction from God to me. I don't care where he wishes, what dimension he wishes to hide in. So, that's the definition. That definition we can take to the bank. Okay? We can use that definition. And if an object does that which has shape and exists means an object that has location, now we can apply these definitions consistently to talk rationally, not like the flat earthers and all other people out there like the mathematicians who go out there and start talking about object and exist without defining those two words. And they use those words constantly, all of these people. Okay? They use them constantly, but they never defined them. All you find in the dictionary, or in the case of exist, are synonyms. And in the case of object, the main one is see and touch. That's what all these people believe in, or that's the notion that they have in the back of their brains. Okay, so here let me give you an object that is invisible and intangible, okay? But it is an object, and it's my electromagnetic rope. Electromagnetic rope is a noumenon, okay? It's part of the noumena that's out there, okay? The mediator of light and gravity, it's invisible and intangible. It's a DNA-like pair of twined threads. We call it the electromagnetic rope because it has the architecture of a rope. Not because it's a rope that you buy at the hardware store, but because it has the DNA-like architecture. That's the only reason we call it a rope. Okay, so people go bonkers over the word rope and they say, well, what do you mean it's a rope? What is it made out of? And then they start with all the nonsense question. No, it's whatever's out there has the architecture of a rope, meaning a pair of twined threads. It torques. When it torques, we call that light. Okay, and yeah, because we can't see it or touch it, we have no chance of discovering it through an experiment. Okay, all we can do is visualize it, and that's why it's a noumenon, because it's a product of the mind. You make an assumption. It's not that you believe in it. It's an assumption. That's what it's called in science. Okay, you make an assumption. Say, let us assume that all atoms are physically interconnected by the electromagnetic rope, a noumenon, something that you cannot see or touch. That's the starting point. It's an assumption. That's known as an assumption. You posit it. Okay, so now with that, you can say, okay, what is light? Well, if the atom expands and contracts, it torques the rope, and the torsion that propagates along the rope, which is really the torsion in situ torsion of that rope, that's what we call light. So we have the object, which is the rope, and what it does, the torsion. And together we call that light. That's how simple it is. Okay, that's the proposal. Do you believe it? We don't care if you do or not. Belief is for churches. Okay, science we explain so that you understand. Once you understand, we draw the line. You cross the line, you're into religion. You're talking about belief, whether you pray to it or whatever. That's your personal business. It doesn't concern science at all. Okay, what are some of the rejoinders that people raise against noumena, such as the electromagnetic rope? Okay, here it is. I can't see them. That's irrelevant. How can I detect them? That's irrational. Why is it irrelevant and irrational? Because noumena, that which you can't see or touch. So why ask a question about see, touch, when that's not the definition of noumena, which is an object that you cannot see or touch? And always I ask the same question there. Why didn't you ask that question to quantum mechanics? I mean, can you see the particles that they're talking about when they say, oh, the photon, the electron, the muon, pion, and all these other particles, the gluon, right? Did you ever ask them, can you see or touch them? Oh, then they're not particles because I can't see or touch them. They're not objects, right? But see, people accept them. They say particles, and people say, oh, okay, I understand that. It's a little ball. And nobody takes it any further than that. They accept quantum mechanics blindly. Okay, they say, yeah, okay, it's a little ball there that does this and that. We call this one a photon. The other one is the electron ball. The other one's the gluon ball. They're all balls. Okay, and you never ask them, can you see or touch them? Okay, so why do you ask me if I can see or touch the rope? If I'm saying it's a noumenon, you can't see or touch it by definition, but you ask the question, and you don't ask the question in quantum mechanics. Okay? Can you see or touch space-time? Okay? Again, take that to relativity, and so on. Okay, so a thing is that which has shape, not that which you can see or touch. So end of story there. How can it have shape if you can't see or touch it? How do you know it has shape? And the answer is, congratulations, you just made the idiot honor roll. Can you prove their existence? Noumena, right? Proof is religion. Proof is in the pudding. Proof is what alcohol has, okay? Religion, that's what proof has to do with. It's opinion, belief, truth, persuade, convince, convert, recruit, knowledge, evidence, all that has to do with religion. We don't try to convert people. We don't try to prove. We don't try to present evidence. Okay, you can if you want, but that's not science. Science is mechanism in physics as it relates to physics. And the electromagnetic rope essentially explains light and gravity. That's the purpose of positing that there is an electromagnetic rope, a noumena out there, a noumenon, okay, that we're going to use to explain a mechanism so that you understand it, not so that you believe it. Okay, so that you can try to visualize and say, well, is this how the universe works? Okay, so it's food for thought. Okay, and people say, well, I don't believe in it. I don't care. It's irrelevant if you believe or not. Okay. Okay, so that's noumena for you. Okay, and hopefully we move on to another subject, which is knowledge. A lot of people have questions regarding knowledge. Okay, so let's go on with that. And where do we start here? Well, we start with a person who essentially criticized the notion that knowledge is something that you have to prove to someone else. Okay, because knowledge essentially by the Greeks was defined as belief. No difference between knowledge and belief. If anything, knowledge is deeper belief. You believe more strongly when you have knowledge than when you just believe. That's more or less it, but it all goes down to you. Knowledge is something you have yourself because belief is what you have yourself. And there are different degrees, and we say that 100% belief is knowledge, more or less. That's the notion. And but I'm saying that knowledge is something that you must prove to someone else. Um, that's the only way that we can really use that in a way that we've been using it all these years. How do you prove knowledge in college? Well, you go up there and you try to persuade the teachers that you know. That means you're going to try to convince them that you know of your beliefs. Okay, that you know what you studied, or you think you know at least. Okay, so this fellow says, no, you don't prove knowledge to someone else. So he says the following, he says, knowledge needn't include proving something to others. Aha. Knowledge exists as soon as it is discovered, not as soon as it is proven to enough people. I see. Well, let's first put my definition so that you can see why where he comes with all this, with his version, his rejoinder essentially. Okay, and this is it. Despite deriving from the word knowledge, science has nothing to do with knowledge. Okay, so the word "sire," that's where science comes from, has to do with the word know or knowledge, and that's where the word science comes from. That's the etymology. But we don't care. Our forefathers screwed it up from the start when they identified science with knowledge. Okay, so we're criticizing that. We're negating that, and we're saying that no, the science has nothing to do with knowledge. Science has to do with explanations. Okay, and knowledge, this is our definition: knowledge predicting to others, right, the result of an experiment without error. That's what all these people have been saying all these years. That's what we're arguing here. We're saying that knowledge is what you prove to others. Okay? And not even God, omniscient God, can predict the result of an experiment without error. If he can without error, that means the future already exists. The block universe, general relativity's block universe. And you can take it all the way to the days of Augustine, St. Augustine, and you'll find that, they've always had this notion of the block universe, that God sees the future, the past, the present, everything at the same time. So that's the block universe. But if that's the case, then if you believe in that, if you accept that assumption, well, that reduces you to a cartoon character. It means that you're just following footsteps that you cannot avoid because the future's already been determined. Okay, so if the future's already there and then all you're doing is just walking in footsteps, and you're no different than Bugs Bunny in a cartoon character. So hopefully you don't accept that as an assumption or as a belief that the future already exists. Okay, it is there. It's already made up. because if you do, you have no free will, meaning that whatever crime you commit, you're off the hook because you had no choice. You were forced to do it because that was the script. You just followed script, whether you knew it or not. Had to follow script. The cards were already thrown. So that's the problem with accepting uh, that we know. Okay, and know again means, like it says there, predicting to others the result of an experiment without error. And you cannot predict. And some people say, well, yeah, I can predict that. Yeah, let me get this out of here. I can predict that this pencil is going to fall to the floor downwards 100% of the time. And I can play a joke on you and put a couple magnets and have it stand in the air. Or maybe I don't even need that. Maybe an asteroid comes and destroys the Earth and your prediction didn't come true. Of course, I can't collect my bet. Or maybe it kills you alone and you didn't get to, prove your experiment. So we cannot prove without error anything in the future. That's the issue. Okay, anything can go wrong. Usually it doesn't, or sometimes it does. Murphy's law, right? But you cannot predict everything in the future 100%. That's the point. So there is no such thing as knowledge, but that is the definition of the word knowledge that we can use consistently. And you say, well, is that true? Okay, so let's go through it. Let's first look what the Greeks said about knowledge, and I covered that the other day. Knowledge, a true judgment with an account. In other words, justified true belief. That came from the mouth, I guess, of Socrates, and Plato wrote it in his book, the Theaetetus, but he put the words, he gave credit to Socrates, okay? So, yeah, knowledge is just justified true belief. That means you're justified yourself, right, in believing it. That's all that knowledge is. And again, I call it deep belief. It's knowledge is just a deeper belief than regular belief, you could say. That's all it is. But it all dies with you, okay, according to the Greeks and according to the notions that we have today. And I'm trying to change that. I'm saying, look, we don't have any use for the word knowledge in science, but if you're going to use it, this is what you always have meant by it. It's the only way you can use it consistently, and that is predicting without error the results of an experiment. I mean, if you go to college and you're in front of the board there trying to get your degree, you are going to try to prove your knowledge to them. How do you prove it? Well, you run an experiment, and you say this is what's going to happen. I put the red liquid with a green liquid, and it turns blue. You can say something, and then you explain why, maybe. And then, so now you have an explanation. You predicted the results of the experiment that you were about to run. That's how you prove it. Can you prove the past? Well, let's find out. Let's look at some of the uses that we have of the word know or the word knowledge, and we're going to see why it's become so complex to understand the word knowledge and why people have irrational notions of what knowledge is. Let's go with the first one. Okay, here. Do you know that, for example, the Pythagorean theorem, that c squared equals a squared plus b squared? Do you know that the number pi, for sure, that circumference divided by diameter is equal to 314, etc., etc., etc.? Force equals mass times acceleration, E equals mc squared. You say, well, I know this. You do you? So what did you just say? What do you mean you know it? What is the definition of knowledge if you're going to say that you know that you know this? So I need a definition of the word knowledge before you can say, I know that this is true or whatever, that I know this. Okay? Maybe you memorized it. Did you run an experiment? How do you know this? Okay? So that's the first one. Did you just memorize it in high school and you say, I know it, meaning you can recite it? So I need a definition of the word know if you're going to use it to say that you know any of these things or any other equation or whatever you find out there. Okay, that's the first one. Let's go with the second one here. Do you know history? Do you know that Alex the Great slept with Hephaestion? Do you know that Caesar crossed the Rubicon in 49 BC? Do you know that Hitler attacked France in 1940? Were you there? I mean, and even if you were there, it doesn't it's worthless because are you going to prove it to me? How are you going to prove, for example, that Neil Armstrong, right, stepped on the moon in 1969 today? How are you going to prove that? You're going to run an experiment and say, look, this is the foot of Neil Armstrong and this is how he stepped on the moon in 1969. Is that how it's done? Is that how you prove that man stepped on the moon for the first time? So you can see we're going to use the word no in different contexts here. And what I need is a definition of the word no that includes all of them. If you cannot define it with all of them, then we got a problem. Because you cannot say that you know that Neil Armstrong stepped on the moon in 1969, that you know that circumference divided by diameter is pi. You can't say you know because you haven't defined the word no. I don't know what you mean when you say no. Okay, so that's going to be the issue here. Okay, here's another context, okay? Do you know that you have a head? Do you know that you cut your hand, you're bleeding, that you have two legs, and that there's a wall to your right? Do you know this? Say, yeah, I know. Well, what does it mean? How are you going to define the word no in such a way to encompass all of these different situations? That's the question before you. Okay? Let's see if we get it right. Here's another one, another context. Okay? Do you know that God exists? How about time is warped? You know, space-time, time is warped. Do you know that time is warped? Or do you believe it? Do you know that a particle can be at two places at once? Do you know that black holes suck? Do you know? Do you know where you're going to? La, da, 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 da. Yeah, you got to define the word no if you're going to be using it in a scientific context because people want to include the word knowledge, no, into science. Okay, fine. Define it in such a way that we can use it consistently in all of these contexts. Okay. If you're going to eliminate one of the contexts, you got to justify why because, you know, I know history. I know that Napoleon went to Waterloo in 1815. And you say, well, that's not knowledge. Okay, then why isn't it knowledge? Do we believe that? But we don't believe. We don't believe that circumference divided by diameter is pi, 314. That's not a belief. That's a knowledge. And you say, well, I can apply it in technology. I can do stuff with circles and diameters and so on. Well, Socrates already killed that one 3,000 years ago. Okay, so just check the Theaetetus, and you'll find that he already tore that notion down. Okay, so you got to read it. Okay. Okay, how about this one? Do you know that a spoon will fall when I let go of it? Do you know this? And you say, well, I do know. You know, here's a here spoon. Okay, little spoon. We let go of it. It falls down. And it turns out that you know I had air pushing from below just when you threw it, and so you did not know that it was going to fall because it's standing in the air. You say, oh, you tricked me. Irrelevant. Irrelevant because the issue was whether you knew, whether you could predict the result of that experiment without air. Okay. Do you know that the sun will rise tomorrow? Do you know that there will be an eclipse in a minute there in that situation where the moon is covering the sun? Do you know? What do you mean you know? What's the definition of knowledge? That's the question. Do you know that the plane will crash? You know, some things we say, well, that's going to happen. And maybe something else happens and it doesn't happen the way you thought it was going to. Your knowledge was not complete for some reason. Okay, how about this one? Do you know Johnny? Do you know where he lives? Do you know who your boss is? Do you know your left from your right hand, right? Um, like I said, in other languages, like Spanish and German, they have different words for these types of knowledge. When you know Johnny, they don't use the word know. They have a different word for those, almost in every language. The only one that I know of is English that doesn't have a word for those, which is kind of it's like acquaintance more than knowledge. Okay. But anyways, again, you got to define the word knowledge in order for us to use it in all these different contexts. Okay, here's another knowledge, and here we're going to be talking about theories. Okay, here it is. Do you know what causes gravity? Is that the same thing as knowing that Napoleon went to Waterloo? I mean, are we talking about the same type of knowledge here? Uh, do you know that a magnet attracts another? Is this knowledge, or are you supposed to provide a mechanism, an explanation, a physical interpretation? Do you know what electricity is? Do you know what prevents the Earth from flying out of the solar system? Okay, these are the questions that you've got to answer if you're going to define the word knowledge and include it within science. And I'm saying the only one that is applicable, and again, there's no knowledge, but the only one that would be applicable is the notion that we have where you prove to someone else your knowledge. If you're on an island all by yourself and you cut your arm, you say, well, I know I cut my arm. I see it, I feel it, I know I cut my arm. I know I have a head. I know I have two arms. I know I have two legs. You know this. But see, whatever knowledge you have yourself is just a belief. What's the difference between belief and knowledge if you're the only person in the universe? Knowledge is something you're going to show someone else. You're going to say, let me show you that I know. Because otherwise you just have a belief. And if you're going to say, look, I cut myself. I know I cut myself, but I'm on the other side of the world and I can't see you or whatever. What am I supposed to say? That you believe until you prove it to me? So again, the issue is defining the word knowledge in such a way that you can use it consistently in science, if you're going to bring that word into science, such that you can use it in all these contexts. If you reject any of the context, you have to also justify why, because that's how it's used in ordinary speech, in all these contexts. We got that? Okay, let's move on to our science critic. Okay, and this fellow, he thinks that an explanation is just a description. And so many people believe that. In fact, all of mathematical physics, on the one hand, they say, well, it's not a description, it's not an explanation. Then they say exactly the opposite. They say, yeah, the explanation in the end is just a bunch of descriptions. So they haven't figured out the difference between an explanation and a description. This is the problem. Okay, so let me turn this fellow loose so that you know what the issue is. Here it goes. Pay attention. The issue to be addressed in this rebuttal is a description the same as an explanation?
Now, another thing that I take issue with that he said is science only explains, it doesn't describe. Well, I'm sorry, but a description can be an explanation. The only real difference between a description and an explanation is a description is describing how something is. An explanation is answering a question. So if you ask the question of why is the sky blue, you'll receive an explanation of Rayleigh Scattering. But Rayleigh Scattering is a description of what's happening there. And that description explains why the sky is blue.
Okay, so he gives this example, Rayleigh scattering. And so if you look it up, you'll find the same thing that I found. And I found it in hyperphysics. Here it is. And here you can see the difference between a description and explanation, which this fellow did not understand. I mean, on the one hand, he says, look, one answers a question. But it's like he didn't listen to what he was saying. Okay? So here it is. This is description, and this comes all out of the same place. Rayleigh scattering refers to the scattering of light off of the molecules of the air and can be extended to scattering from particles up to about 1/10 of the wavelength of the light. So far, all we have is a description. We have no idea why the sky is blue so far. Okay, all they're saying is that molecules scatter light. That's a description. Right now, we have no explanation of anything. Now comes the explanation of the mechanism, of the cause, okay, of what? Of why the sky is blue. It is Rayleigh scattering off the molecules of the air which give us the blue sky. And now you can go into more detail and say, look, this is the explanation of why, what causes the sky to be blue. But you cannot go with the first paragraph there and say, oh, that explained it, explains why the sky is blue. So you can see a little bit of a difference here, and this is just in general terms, just so you can see the difference between a description and an explanation. Like he says, an explanation answers a question, a description does not. But he doesn't understand what he said. Okay, this is so you wonder about his mental state or what is going through that, through between his ears. He's got very little to block the information that's going through there. Anyways, here, let me give you an example. Okay, another example. This is referring to the rope. Okay, here it is. Here's a picture or a movie, right, of two atoms bound by the rope. So far, you have no explanation. So far, all we've got is a description. It's an illustration, and you can say, okay, two atoms, they're apparently expanding and contracting, and there's a rope between them. That's a description so far. Unless I give you some background, talk it behind, and tell you what you're staring at, what this is all about, you won't have any idea that that rope torquing there is supposed to represent light. Okay. Now, I constantly say that you need to make movies of your physical interpretations, okay? Because if a picture is worth 1,000 words, a movie is worth 1,000,000 words, okay? So keep that in mind. But the issue here is very simple. I'm on the one hand giving you a description of the mechanism, but unless I tell you what I'm trying to explain, what I'm trying to answer, you will not have an explanation. All you will have is a description. Okay? Mathematics can only describe. An equation is only a description of a dynamic situation. That's all an equation is. So all you have is a description. If you want an explanation, you won't find it in mathematics. You'll have to go to physics. And that's where the problem is, because the mathematicians have united or extrapolated mathematical concepts into physics and purport to explain how this universe works by using mathematics, by using equations. But again, all that is a description. Both of them are how something works, meaning how it works in the sense of how fast it works, how much time. That's different than saying how it works, like what is the mechanism. Those are two different hows. It's like if here you're talking about the why, and by why I don't mean purpose and reason, I mean cause and mechanism. So in that sense, the why is not a how. Okay, and so those hows and whys, they get them mixed up constantly. That's the big problem. So anyways, no, an explanation is not a description, and description is not an explanation. Explanation answers a question. Okay, so keep that in mind. That is the answer to his rebuttal. Okay, and so let's move on here to some of the questions that people asked since last time. And first guy says, when we agree black holes do not exist, we apparently do not agree on the explanation for why they do not exist. It is all imaginary. That's why they don't exist. So he's saying that non-existence is equal to or identified with imaginary. There is no need to prove, meaning prove, an object exists. Yeah, there is no need. You just follow the definition. Because we can see and touch it. So again, all these people, these flat earthers, they believe that existence has to do with see and touch. That's what it means in their tiny brains, because that's what they have in ordinary speech and in their everyday world. But when they come into science, they want to bring that irrational definition over, and that's when we stop them. We say, no, no, you can't use that definition here. That definition is an irrational definition that can be used over there in ordinary speech. You can say love exists over there if you want. In physics, you cannot say that love exists. You can say energy exists over there in ordinary speech. You cannot say energy exists in physics, okay, in science, okay? For that, you need to define the word exist very, very precisely, because physics is the science of existence, okay? So keep that in mind. Okay, and says, objects do not need any location. For how then can objects exist that I myself cannot see or touch? Well, you cannot see the air. I mean, does the air exist? Again, all these people, they have tiny brains. They really have. They don't have the ability to think these things over. Does the chair of that Australian on the other side of the planet, does that chair exist? Is that an object? What is he sitting on when he calls you on the phone? He's calling you on the phone, you're talking to someone, he says, I'm sitting on a chair. Well, I don't believe a chair is an object, your chair, because I can't see or touch it. And I don't think it exists because I can't see it or touch it. Is that a rational statement? This is what this fellow is saying. Not every object I know to exist has a fixed location within my observational distances. So he's got this tiny world that only that, like this other person said, anything that he can see or touch, that's his entire world. Anything beyond that, he says, I don't believe, I don't accept. But he doesn't realize that if he does that, he's essentially saying that the chair that the Australian is sitting on is not a physical object, and it doesn't exist because he cannot see or touch it because it's outside his what? Observational distance. That's how irrational this individual is. And so you are the one claiming invisible objects even exist, not flat earthers, correct? And hopefully. And the burden of proof is on you. No, this has nothing to do with proof. It's got to do with making an assumption about noumena. You know, it's are there objects that we can't see or touch? Is the air an object? Is it a thing? Is it made out of atoms? If not, tell me what it is that you're sweeping when you move your hand. Okay? What is it, a spirit, a ghost? What are you breathing? You know, something's entering your mouth, right? Tell me what. Okay, draw it. How are you going to draw it if you cannot visualize it? If you say, well, I don't believe it exists because I can't see it, well, I don't know. I don't know what to tell you. You got to define the word exists in such a way that you can use it consistently. You have to define the word object also in a way that you can use it consistently. Okay, and here's another fellow. He says, could you explain quantum computers? Yeah, quantum computers is a sales pitch. That's all it is. Okay, they put the word quantum to say, just to reinforce that they've proven quantum mechanics. That's why they put the word quantum. The only reason they put the word quantum in there. They say that quantum computers have some of these features that they drew from experience at the accelerators. Photon orientation, electron spin, superposition, entanglement. The problem is they've never verified any of these. They don't know what causes entanglement. They don't know the mechanism that underlies superposition or electron spin, which is not spin, by the way. It's not a top spinning. They don't know what photon orientation. They've never seen a photon. So what are they talking about? Photon orientation. So what happens with all these things? They go to the lab. They have the visible part and the invisible part. The noumena, okay, stuff that they can't see or touch. And the stuff that they cannot see or touch, they infer. They infer that it's there under the particle model. So they give it an explanation under the particle model. That's the issue. And they say, we don't understand it. Well, if you don't understand it, how did you build a computer with it? Well, they take the effect. It's just like Edison. Thomas Edison invented the bulb, right? That could be usable, that could be sold out there. a workable device. And he said, and he never understood electricity. He didn't know what electricity was. No one to this day knows. The electric universe especially doesn't know what electricity is. So they're called electric universe. They don't know what electric means. Okay, so if they don't know today, certainly good old Thomas Edison didn't know in those days. He didn't need to know. He just needed to know that he tried one thing after another until he got it right. In fact, he says, I have not failed. I just found 10,000 ways that don't work. That's how he did it. He just tried one thing after another until he got it right. He doesn't have to understand any of that. And this is no different. Quantum people, no, there's not a single quantum individual on planet Earth, quantum so-called physicist, mathematician, that can tell you photon orientation. They have no idea because they've never seen a photon. They have no idea. They infer that there's a little particle and it's got some kind of orientation. They don't know what electron spin is. They don't know what spin is. They can't define it. They don't know how superposition works. They say they don't understand it. They have no idea how entanglement works. They just say it does. And they use that it does to do technology. So they're using some of these features which they do not understand. And that's where the theory should vibrate. A theory is an explanation of the mechanism. If you do not know the mechanism, the fact that you can use it to do technology does not allow you to use the word quantum, meaning, in the name like quantum computers, meaning or implying that your theory is correct. The theory is not correct because they cannot explain it, and theory is an explanation, not a description. And right now they have descriptions, no explanation, so they have no explanation for any of these. So the word quantum is put in there just to fool you into believing that their theory is correct, that quantum has been proven and it's a done deal. That's the only purpose of putting the word quantum. And the answer is no, the quantum has not been proven, especially the physical interpretations. That's why to this day they all say, every single mathematician out there says, we don't understand how quantum works. If they don't understand the mechanism, they don't have a theory. Quantum is not a theory, it's a description. Okay, and it's a description based on the particle hypothesis, discrete particle hypothesis, which is irrational to begin with because you cannot explain any phenomenon with particles, assuming they were particles, which they ain't. The particles of classical mechanics died at the end of the 19th century. What came after was quantum mechanics, and they left behind classical mechanics. So the particles are not particles. The so-called particle is a number. That's what it is. Okay, so until you understand all that, you haven't understood anything about quantum mechanics. Quantum mechanics only deals with numbers. It's a description. It has no explanation, no mechanism. So they don't know how it works, but they know it does work. It's like electricity. You get zapped by electricity, right? And it turns on the light. You don't know what it is, but it turns on the light. That's good enough for you. You can use it to do something, some technology. And so you say, I'm going to use electricity. So what's your theory of electricity? Do you know what electricity is? Oh, I don't know, but it works. And I can make this device with it. I can turn on lights with it. So that's the situation with quantum computers. They don't understand any of the theories. They don't have an explanation of physical interpretation. They just know the effects, and they use the effects to make technology. And they call it quantum, and people are fooled into believing that quantum has been proven and the theories are correct, etc., etc. Okay, here another fellow asks, he says, belief is a consequence of owning a thing and pursuing an understanding of it in order to control the destiny of its ownership and the destiny of yourself as its owner. Belief all by itself is insubstantial and of no consequence. It transfers responsibility to whoever sold you this belief. Okay? Hence, you are at the mercy of whoever is its author. Belief is for children, not for adults. I like that one. Yeah, belief is for children. We don't care about belief in science, okay? So any person talks about knowledge or belief, I guess they're children. We can say that, right? In science, we make assumptions, we explain mechanisms as it relates to physics, and then you can believe whatever you want. Okay? Belief is the part that belongs to religion. It doesn't belong to science at all. And that includes knowledge, which is just more profound, more deeper belief. That's all knowledge is. Okay, another fellow says, we know something is true if it is in accordance with measurable reality. Measurable reality. Deciding whether a statement is true involves memory. Yeah, but it's just your opinion. You know what is true? It's true to you. Is God true? Well, ask out there, and you'll find a lot of people who say that it's true, that God is true, and another person will say that God is not true. So who's right? I mean, does it involve memory? I don't know if it involves memory or not. I'm saying it's irrelevant. Determining one is false relies on reasoning and problem solving processes such as the scientific method. Now, science doesn't deal with falsehoods or with truth at all. Science doesn't care about true or false. True or false are always opinions. Okay, and you say, well, what if we don't have facts out there? We don't have truths out there. Facts and truths are what Mother Nature knows, Father Universe, God, whoever you believe in. But they know exactly what happened, how the universe works. But they've got all that information locked up in their cabinet. You can't interview Mother Nature and say, well, am I correct? Is my truth the same as your truth? We have no way of verifying that, of confirming that. So all we end up with is believing in certain facts, and this guy believes in this fact, the other guy believes in another fact. That's all we have is, again, beliefs. And the way we do in science, we don't care about beliefs. We say, let us assume. Okay, so we make assumptions so that the person can follow our dissertation. We build our theory on the assumption that we made. That's the way it works in science. Okay, here's a fellow, he says, Bill, have you ever seen the ropes? A person who doesn't understand what noumena are, okay? No, objects are not that which you can see or touch. Have you ever seen the air? Is that does that mean there's no such thing as air out there because you have never seen the air? Again, it's all these people who are bent on talking about see, touch. Objects, not see or touch. Existence, also not see or touch. Electromagnetic ropes are invisible and intangible. Object is that which has shape. Electromagnetic ropes have shape. We're done. We're talking about an interconnected universe. Okay? That's an assumption. We say, let us assume that all atoms in the universe are interconnected. Now that we made the assumption, you take the assumption at face value to understand the theory. Now we move on to the theory and explain the mechanism, the physical interpretation. We explain. Okay, that's what science is about. Just objectively so that you understand it. That's the purpose of science. Understanding. Explanation and understanding. And last question or issue. Person says, all atoms are interconnected. Yeah, that's what we're proposing. Where has this been demonstrated for us then? Can you show us? It's invisible and intangible. He wants me to show it to them. Well, yeah, here I can show you a mock-up of what I'm proposing. Okay, here's a rope. You can think of the fists as the atoms, right? And they're connected by a rope. There, I showed you. That's what I'm proposing. What part do you not understand? I'm saying that that's what's out there. We can't see it or touch it, but that's how you would simulate it so that you understand the theory I'm proposing. Okay? Do you believe it? Well, we don't care. We don't care because it has nothing to do with science if you believe it or not. We're trying to explain to you so that you understand it and then you can reach your own conclusion in private. We don't want to hear your conclusion either. Okay? So just keep it to yourself. You don't have proof of these atomic interconnections. What proof do you want for invisible, intangible entities? What am I supposed to bring for proof? The proof is in the pudding. And they say, all I can show you is the mock-up of what I propose. And I'm saying light would look something like this, like a DNA, like a twisted rope, right? And it torques, right? There's this torsion going on, and that's light. That's what I'm saying. That's the explanation, the theory. Do you believe it? We don't care. Yeah, you believe it exists. No, I don't believe it exists. It's an assumption. It has nothing to do with belief. But these people harp on belief, on prove it to me. Bring the evidence. Show me the invisible, intangible. So what am I supposed to do? They have mental problems. They don't understand what we're saying, what we're proposing here. We're proposing explanations. That's what it is. Okay, so how do we do it in science? Well, here it is. Let me put it over here. Science, we say, we begin by making assumptions, okay? And the assumptions are known as hypotheses, and it includes the objects, the definitions that we're going to use, and the statement of the facts. There are no facts. Facts is what Mother Nature knows. We can only make a statement of what we think happened or is out there. We can only make a proposal, an assumption, especially about the invisible, intangible stuff out there, like the mediators of gravity, light, and magnetism, and so on. So we make an assumption, and this is where it starts. It's not a question of belief; it's a question of assumptions. The assumptions are known as hypotheses. And we build there so that you can follow the dissertation. We say, okay, these are the objects, these are the definitions I'm going to use, and this is the first few frames of the film. I'm going to give you the starting point, the scene. I'm going to paint the scenery, describe it, okay? So I've got that. Now on that, I'm going to base my theory, and that's what science is about, the theory. Okay, and so what science does now, it gives you an explanation, a mechanism, physics, right, of how something works. For example, gravity or magnetism. You make an assumption, and based on that assumption, you give an explanation, an objective explanation, so that the person understands the mechanism. Has nothing whatsoever to do with belief. Okay, okay, with that, I'll see you next Sunday, and we'll see you then. Bye-bye.